On this problem, we're going to come up with a formula for h of x that satisfies the graph given. Now we are given a maximum here at negative pi halves at positive 5 and a minimum at pi fourths and negative 4. I've highlighted where the midline will be, but let's talk about that first and get that calculated exactly. Okay, so the way you want to find the midline is by averaging the mins and maxes. If you think about it, the average height of this wave will put you right in the middle of it. So that's what we want to know. So just some real good scratch work. Midline over here, the average of the mins and maxes is going to be 5 plus negative 4 divided in half. So that's going to add up to 1 on top. So the average of 5 and negative 4 is positive 1/2. So our midline is going to be plus 1/2. That's this term down here. Now, using the midline and knowledge of the mins or maxes, we can figure out this amplitude value. What's the height from the midline, or I should say the distance from the midline to the max, which will also be the same as the distance from the midline down to the minimum. So this is actually not a tough one at all. You can just count that it's 4.5. So I'm going to go 4.5 for my amplitude. And the next thing we're going to want to do here is make up our mind about whether this is a sine or a cosine. So making the choice between, is the formula for this model going to be better suited as a sine or cosine? And this has to do with what anchor points we know. We clearly have a max and a min given, and cosine is what we gravitate towards when we know one of the extrema. If we only know a midline point, sine would be the better choice. But like I said here, we're going to go with cosine, and I'm going to use this maximum as the one I kind of zero in on. Normally, cosine would start at the top of its amplitude right on the y-axis, but this is what we call a phase shift to the left. So I'm going to highlight or pencil in here cosine, and at the same time, I'm going to also talk about the phase shift as it being left pi halves. Now you see that I wrote in here the x minus c. So really this is like what I've got below there is x minus negative pi halves is one way to think about this. But whenever we have a horizontal translation, an interlayer shift, where the graph moves left or right, left is going to be a negative value on the x-axis, but ends up with a double negative in the formula. So that's why we see this as a plus pi halves. Okay, so you basically look at where it should be and where it actually is, and that was a movement left, so we are writing in plus pi halves. Okay, last thing to figure out here is the b value. So you can see the little formula I have there, 2 pi over 1 period will give us the b value, and we're not actually given the period, although if you look from that max down to the minimum here, that is half of a cycle. And so if you focus on the x values, you can figure out the length of half of a cycle. So what I'm going to do here is say 1/2 of a period, and I'm going to use kind of this slang here, big minus little. We're just finding the length between 2 points on the number line. So the bigger x value is this pi fourths. So pi fourths minus, and this is the little one, negative pi halves. We're just looking for the distance between those two x values. And it'll be a double negative. So we have pi quarters plus pi halves. We're pretty familiar with quarters and halves. You could think of this as 1 pi quarter plus 2 pi quarters. Okay. Which is just getting a common denominator there. So really we have 3 pi fourths, 3 pi quarters. That is 1/2 of the period. Now, we actually want to know what 1 full period is. So this becomes an easy scaling problem. To scale from a half to a full means we're just doubling. So I'm going to double 3 pi fourths, and that's going to give me, to double something, you just double the top on a fraction. This will be 6 pi fourths, which is reducible. That's going to be 3 pi halves. Okay, so in order to figure out b, I need to take this 3 pi halves and plug it in to that b equation I had here. So now that I know a period, I can do this. So b is going to be 2 pi over 3 pi halves. Now, whenever I have division by fraction, I like to reframe it as multiplication by the reciprocal. Okay, so instead of saying 2 pi divided by 3 pi halves, I'm going to say 2 pi times 2 over 3 pi. And here we could see the pi's will reduce out, and the rest of it's pretty streamlined from there. We get 4, 2 times 2 on the top, 4 over 3 times 1 on the bottom. So our b value is going to be 4/3. Now, I know in systems like Khan Academy, they don't often show the formulas here with these extra parentheses inside. For some reason, a lot of problems in textbooks and places like Khan Academy, they will just distribute the 4/3 through this quantity so that they just have one layer inside here. I really like leaving it separated because then I can obviously see the phase shift of pi halves to the left and extract the b value whenever I want to. So I've done some checking. If you type this in precisely as I have it here, with the parentheses as I have them, you'll get that right in the system. So good luck. I hope that helped. Thank you for your question.